is lesson 97 in Saxon's Algebra 1, the third edition. This lesson is going to cover a couple things, angles and triangles. It's a review of that. The Pythagorean theorem, there we are with that theorem word again, and then Pythagorean triples. Okay, so it's a little bit longer lesson than we've been having, so let's get right to it. This says, we read this like this: the measure of angle A, this, plus the measure of angle B, this, plus the measure of angle C equals 180. Because we know that we can see that this is a much bigger angle than this, and this one is even bigger than this. We don't know their individual measures, but we can know that together they all three are going to equal 180 because all triangles have a measure of the three angles equaling 180. So we have different kinds of shapes of triangles. We have the equilateral, and if it's an equilateral and we've got these little tick marks here, those show that these are all the same. Equilateral, equa meaning the same and lateral meaning sides, same sides. Those will always be 60-degree angles, three 60-degree angles, because they're all exactly alike. Then you have the isosceles triangle, in which two sides are the same, but this angle at the top is going to be smaller. So you've got 65 plus 65, which is 130, and then this top angle is smaller than these, so it is 50. Then you've got the scaling triangle, which really doesn't have any sides that are alike. And in this one we've got 120 plus 20 is 140 plus 40 is 180. So you see that no matter what the shape of the triangle, the measures of the angles are always going to be 180 degrees. Now, this lesson is going to deal primarily with a special triangle called the right triangle. The right triangle, in this one, it has a measure of 30, 60, and 90 degrees, but a right triangle will always have a 90-degree angle. That's what makes it a right triangle, okay, that right angle. And a right angle is always 90 degrees, so that only leaves 90 for these other two to have split among them. I found this and I really liked it. It says, "Great Scott, my math teacher was right. I did need to know Pythagorean theorem. Curses. Now poor Timmy is going to die because of my foolish disrespect for geometry." Pythagorean theorem is one of those things that does have lots of real-life applications. So, but in Saxon's wisdom, we're not going to have to really memorize a lot. We're just going to memorize it by doing it over and over. So this basically in a nutshell is the Pythagorean theorem. It says that a squared plus b squared is equal to c squared. In a right angle, and this only works on right triangles, by the way. You can only use Pythagorean theorem on a right triangle. So on a right triangle, you've got a leg, and then this long leg here, which is called the hypotenuse, and the hypotenuse is always going to be C. It doesn't matter which one of these is A or B, but the hypotenuse always has to be C. How do we know which two make up the leg? Well, I'm glad you asked, because it's the two that come together to form the right angle. Okay, so we've got A here, B, and C is the hypotenuse, and a squared plus b squared is equal to c squared. Let's look at that a little more in depth. So this is why we know this works. If A, for example, were 3 and B were 4, then we can know that C is going to be 5 because A squared, which if we square A we get 9, B squared, 4 squared is 16, and 9 plus 16 is 25. 5 squared is just that. It's 25. So if this is 3, if this is 4, then this is going to be 5. This shows it in just another way here, but you've got 3, 4, and 5. Okay, so let's work a problem here. Example, find side P. All right, well, P is our hypotenuse, and if A squared plus B squared equals C squared, I forgot to square that A, didn't I? These are the two that come together to form the right angle, the 5 and the 4. So we're going to say 4 squared plus 5 squared equals C squared. Alright, so 4 squared is 16, 5 squared is 25 equals C squared. So 16 plus 25 is 41 equals C squared. And just like we did in one of the last couple of lessons, to get rid of this square right here, we're going to have to put everything under a square root sign. So the square root of C squared gets rid of this square sign. So our answer here would be C is the square, or P, I'm sorry, P is the square root of 41. In the second example, it says find K. Now, this is square root of 61. We know the hypotenuse. This is the hypotenuse right here. How do I know? Because these two lines are the ones that come together to form this right angle. So those are the two. Those are the A squared, B squared, this is C squared. So 5 squared plus K squared equals the square root of 61. Squared. So 5 squared plus K squared equals the square root of 61 squared. Alright, well, we know 5 squared is 25 plus K squared equals, sorry, need to make that a little bit more clear. Okay, and as I'm getting rid of my squares here, the square root of 61 times the square root of 61 is square root of 61. I'm sorry, plain 61. So let me undo that. Equals 61. Alright, so if I solve this like a regular equation now, I say 61 minus 25, K squared equals 36. Well, if K squared is 36, then K is equal to the square root of 36, which tells us that K is going to be equal to 6. So that's how you do that. If you find yourself doing your practice, problems in your lesson, and you get stumped up, come back and look at how we are working these, or you can look in your book, follow the steps. Okay, this example says find side M. M in this is, again, the hypotenuse. We've got A can be A, 8 can be A, 12 can be B. So 8 squared plus 12 squared is equal to M squared. Alright, 8 squared is 64. 12 squared is 144. Equals the square root of M. equals m squared. Okay, 64 plus 144 is 208. 208 is equal to m squared. So if I say m is equal to the square root of 208, I just get rid of this by putting this under the square root sign. Now 208 can actually be factored out. 208 is, let's see, 104, 252, 226, 213. So we've got two pairs of 2's that could come on the outside. M equals 2 times 2, which is 4, times the square root of this 13, which is all that is left. And hopefully you were able to follow that without too much trouble. It is in your book. Hopefully explained it just a little bit more in detail than your book did. Okay, Pythagorean triples. Triples means there are three of something. This in the blue is actually a short list of Pythagorean triples. And a Pythagorean triple is three numbers, three integers that fit exactly the Pythagorean formula. Like if you know that one side is 3 and the other is 4, the third side is always going to be 5. If one side is 5 and one side is 12, the other side is always going to be 13. And by extension, then 3, 4, 5, you can do any multiple of 3, 4, 5, like you could do 6, 8, 10 would also be a form of 3, 4, 5. The number of possible Pythagorean triples is infinite, but the main ones that we're going to learn truthfully are these first four right here. I want you to copy all of these into your notes just so you'll have a handy reference, because you never know when you're going to need that. Alright, so let's work some practice problems. A and B say use the Pythagorean theorem to find unknown lengths. Alright, in A we have these 5 and the 6 come together to form the right angle. So we're going to let 5 be A and 6 be B, and we're looking for P. 5 squared is equal to 25. 6 squared is equal to 36. Square root of P. You add 25 and 36, you get 61 is equal to the square root of P. And we can say the square root of 61 is equal to P. And that's just all there is. Alright, in B, can you look at it and tell me which side is the hypotenuse? Well, here is your right angle, so this is going to be A, and this is going to be B, and this is going to be C, okay, in our formula. So 5 squared plus 15 squared is equal to F squared. Alright, now I happen to know that 5 squared is 25, and 15 squared, 15 times 15, is actually 225. So the square root of F. Alright, 25 plus 225 is 250. equals the square root of f. So we can say that the square root of 250 is equal to 5. I'm sorry, I put a 5 there. It should be an f. This should be f. Okay. Now 250 will break down. We can factor that out. Let's say 250, let's go by 5s. That'll go 50 times. That will go 10 times. That will go 2 times. So we have this pair of 5s that we can say 5 times the square root of 10 equals f. Okay, let's go on to the next page. C and D says recall the appropriate Pythagorean triple to find the unknown length in each of the following right triangles. Alright, if you copied down your chart, then this type of problem is going to be so simple for you. You're just going to look in your notebook, look at the chart, and boom, there it is. Alright, so do you remember what Q would be if you've got a 12 and a 13? That's right, Q is always going to be equal to 5. And then if you've got a 6 and a 10, the third side is going to be 8. 6, 8, 10. 5, 12, 13, always. Alright, be sure you copy that chart in your notes, and I'll see you next time for Lesson 98.